forms of cabling are similar in that they provide a medium across which network information can travel in the form of physical signal, whether it's a type of electrical transmission or some sequence of light pulses. The most cabling types used to interconnect networks are coaxial cable, twisted pair cable, both shielded and unshielded varieties, and fiber optic cable. All cables share the same characteristics. Studying these characteristics facilitates your understanding for their function and proper use. So these cable characteristics includes bandwidth rating, maximum segment length, maximum number of segments per internetwork, maximum number of devices per segment, interference susceptibility, connection hardware, cable grade, band radius, material cost, and installation cost. Baseband and broadband transmission. So baseband transmission uses a digital encoding scheme at a single fixed frequency where signals takes the form of discrete pulses of electricity or light. Baseband systems use the only one channel on which all devices attached to the cable can communicate. Baseband systems such as Ethernet use special devices called repeaters that receive incoming signals on one cable segment and refresh them before retransmitting them on another cable segment. While broadband transmission uses analog techniques to encode information across a continuous range of values, rather than using the binary zeros and ones that characterize digital data in a baseband environment. Broadband system signal flow is one way only, which makes two channels necessary for computers to send and receive data. Broadband cable segments are interlinked between devices called amplifiers that detect weak signals, strengthen those signals, and rebroadcast them. There are two primary approaches to supporting two-way broadband communications. The first one is the mid-split broadband that uses single cable but divides the bandwidth into two channels, each on different frequency. So the second one is the dual cable broadband, uses two cable. Each computer or network device must connect to both simultaneously. So bandwidth is highly significant for determining how fast a web page loads on a browser. In fact, it is also one of the essential things to consider while you're choosing a platform for web hosting. Accessing information and services is the name of the game in networking and more. Faster access is clearly better than less and slower access. The higher the bandwidth, the acceptable the quality of service is. Coaxial cable are often called as coax. So coaxial cable consists of a single conductor at the core surrounded by insulating layer, braided metal shielding called braiding, and an outer cover usually called the sheath. Shielding works like a form of built-in conduit, a type of metal or plastic built specifically to contain cabling. Shielding protects the cable from external interference like EMI or RFI. Ethernet's beginnings are in coaxial cable, so the Institute of Electrical and Electronics Engineers or IEE designates these cable types are 10^5 and 10^2 respectively, where this notation indicates. So total bandwidth for the technology in this case 10 means 10 megabytes per second or Mbps and applies equally to both thin and thick varieties. So base, the network uses a baseband signaling for both types of cable. 2 or 5 roughly indicates maximum segment length measured in hundreds of meters, so 2 for 200 and 5 for 500 meters. Whereas the coaxial cables used as a primary medium in LAN applications has become outdated, the use of coaxial cable to access the internet is escalating. Cable modem internet access uses broadband technology to carry internet data signals and cable television channels on the same medium. Other applications of coax include ArcNet and computer terminal attachments to mainframes and minicomputer. ArcNet is an acronym for Attached Resource Computing Network. Twisted pair cable. So the most basic form of twisted pair wiring consists of one or more pairs of insulated strands of copper wire twisted around one another. The twists are important because they cause the magnetic fields that form around the conducting wire to wrap around one another and improve TP's resistance to interference, while also limiting the influence of signals traveling on wire over another. This is called crosstalk. So there are two primary types of TP, which is the unshielded twisted pair or UTP and shielded twisted pair, the STP. Fiber optic cable. So fiber optic trades electric pulses for their optical equivalents, which are pulses or light. Because no electrical signals ever pass through the cable, this fiber optic media is as immune to interference as any medium can get. They emit no external signals that might be detected, unlike electrical or broadcast media, thereby eliminating the possibility of electronic eavesdropping. In any fiber optic cable, each light conducting core can pass signals in only one direction, meaning the one end is always the sender and the other always the receiver. In fiber optic cable characteristics, there are 5 connector types, which is the straight tip, straight connection, medium interface connector, sub-miniature type A, and MTRJ. So fiber optic cables come in 2 primary types. There are single mode cables and the multi-mode cable. Wireless networking has considerable appeal in many circumstances. Related technologies can provide the following capabilities. The first one is to create temporary connections into existing wired networks. The second one is to establish backup or contingency connectivity for existing wired networks. The third one is extend a network span beyond the reach of wire or fiber optic based cabling, especially within older buildings in which rewiring may be too expensive. And the last one is permit certain users to roam with their machines within certain limits, the so-called mobile networking. Commercial applications for wireless networking technologies include ready access to data for mobile professionals, delivery of network access into isolated facilities or even in disaster-stricken areas, access in any environments in which layout and settings change constantly, improve customer services in busy areas such as check-in or reception facilities, network connectivity in facilities, home network where installations of cable is inconvenient. Wireless networks can be subdivided into 3 primary categories. The first one is the local area network or the LANs, the extended LANs, and the mobile computing. The wireless components of most LANs behave like their wired counterparts except for the media and the related hardware involved. The operational principles are much the same. It is still necessary to attach a network interface of some kind to a computer, but the interface attaches to an antenna and an emitter rather than to a cable. An additional item of equipment is required to link wireless users with wired users or resources. That is, at some sort on cable network, it is necessary to install a transmitter or receiver devices called a transceiver or an access point that translate between the wired and wireless networks. An access point device includes an antenna and transmitter to send and receive wireless traffic, but also connects to the wire side of the network. All wireless communications depend on sending and receiving signals broadcast through the atmosphere to ferry information between network devices. Electromagnetic is a signal take the form of waves and is measured in terms of the frequency of the waveforms used for communication, measured in cyclic per second, usually expressed as Hertz or Hz. In wireless communication, frequency affects the amount and speed of data transmission. The principles that govern wireless transmissions dictate that lower frequency transmission can carry less data more slowly over longer distances, while higher frequency transmissions can carry more data faster over short distances. The most commonly used frequencies for wireless data communications are radio, microwave, and infrared. So wireless LANs make use of 4 primary technologies for transmitting and receiving data. The first one is infrared, the second one is laser, the third one is narrowband or single frequency radio, and the last one is a spread spectrum radio. 802.11 wireless networking standard, also referred to as Wi-Fi, completed in 1997. The current standard include 802.11b and 802.11g, running at a frequency of 2.4 GHz at speeds of 11 Mbps and 54 Mbps respectively, and 802.11a, which specifies bandwidth of 54 Mbps. Essentially, 802.11 is an extension to Ethernet, uses the airwaves as the medium. Many businesses are setting up Wi-Fi hotspots in which a person can sit outside their favorite coffee shop and enjoy a wireless internet connection with their laptop, PDA, or even their cell phone. Certain kinds of wireless networking equipment extend LANs beyond their normal cable-based distance limitations or provide connectivity across areas where cables are not allowed to traverse. For instance, wireless bridges can connect network up to 3 miles apart. The wireless bridges always appear in pairs, and both such devices function together as a repeater. That is, whatever comes in on the wired side of one device is transmitted out to the wired side of the other. These devices are sometimes called half repeaters, a reference to the frequency they use. Thus, you may hear this equipment called optical half repeaters for laser or infrared version, or radio half repeaters for the spread spectrum counterparts. One of the latest wireless standards, the 802.16a WiMAX, or Worldwide Interoperability for Microwave Access Standard, promises wireless broadband to outlying and rural areas where last-mile wired connections are too expensive or impractical due to rough terrain. So WiMAX is being considered for implementations that include mobile wireless access, where a person could connect and maintain a high-speed wireless connection on a PDA or laptop while moving in a car. Microwave networking technology. So experts distinguish two types of microwave systems, which is the terrestrial and satellite. Terrestrial microwave systems use a tight beam, high-frequency signals to link sender and receiver. By using relay towers, microwave systems can extend a signal across a continental scale distance. The other primary alternative for microwave transmission is satellite. Instead of aiming at transmitters or receivers within a clean line of sight on the ground, satellite microwave systems send and receive data from geosynchronous satellites that maintain fixed position in the sky. Other wireless networking technologies include cellular packet radio, cellular digital packet data or CDPD, and narrowband sockets.